Okay, a couple more fallacies of weak induction for you in this video. The first is called appeal to ignorance, and this one is pretty simple enough to understand. This one actually has a format to it, even though I said that in formal fallacies the defect has to do with the subject matter and not to do with the form so much. At the same time, some of them have a sort of form that you can at least paraphrase the argument in a certain way. And an appeal to ignorance can always be paraphrased to say there's no evidence that something, right, P, and therefore P is false because there's no evidence that it's true, therefore it's false. And this type of argument is a fallacy because, right, the fact that there's no evidence or there's no proof that something is true, it doesn't mean the opposite is true, right? So the classic case of an appeal to ignorance, if I was to say, well, let me give you, actually this is not a classic case. Let me give you my own case of, so let me give you my own made-up case of appeal to ignorance. Suppose we're eating at a restaurant and you get your food, you get a hamburger, you're about to take a big bite out of your hamburger, and I say, hold on a second, don't take a bite out of that hamburger until you consider this. How do you know that they didn't spit in it, right? You weren't back there, you weren't in the kitchen watching them make it. You have no proof that they didn't spit in it. I don't think you should eat it. I don't think you should ever eat in a restaurant because you can't prove that they spit in it, so you're probably eating spit all the time. Well, you know, the fact that I can't prove that they didn't spit in it, that there's no spit, is not evidence that there is spit, right? And in this case, the famous saying applies, right? The absence of evidence is not evidence of absence, and this works both ways, right? You can make the argument, well, there's no proof that there is spit in there, and therefore there's no spit. These arguments both commit the appeal to ignorance, and so either of those arguments would be a fallacious argument about whether there's spit in the hamburger, whether there's not spit in the hamburger, and neither of them sort of tips the balance, right? So then we have to consider, well, what's the sort of default assumption, or what would be the other reasons why you would assume that there is no spit or that there is spit, right? So bringing up this appeal to ignorance, the point is that it doesn't really tip the scales either way to say that one thing's not proven in the other when the other's not proven. So there is an exception to this, and it's important to bear in mind when you're looking at an argument that has this format, an argument that can be paraphrased in this way, might not automatically be a fallacy. There is one sort of out. There's one exception. And that is when, if the thing were true, you would have proof that it was true. You'd have at least good evidence that it was true. So, for example, if I say, I don't think there's a tiger in the room with me now. I don't think there's any tiger, and that's because I don't see a tiger, I don't hear a tiger, and right, I don't see any evidence, hear any growling or you know, anything else that would come from a tiger, smell it. Now nobody should say, wait, that's just appeal to ignorance. You shouldn't be so sure that there isn't a tiger in the room with you, right? Just because you don't see the tiger, right, doesn't mean there isn't a tiger. The absence of evidence, not evidence of absence, right? Well, in this case it is, right? Because if there was a tiger in the room with me, I would know, right? This is almost certainly, I would know that there was a tiger because I would see it, I would hear it, I would be getting ripped to shreds or at least stalked. So when that's the case, you can give this type of argument, right? When it's something, if you knew it was true, or sorry, if it was true, you would have evidence that it was true. And maybe we'll look at, look at more sort of realistic cases later, because this gets sort of interesting. But for now, let's go to the next fallacy, which is called hasty generalization. This is like a key fallacy of weak induction. And a lot of the other fallacies resemble hasty generalization, and so I worry that students will just, anything they're not sure on, just label hasty generalization. And that's not necessarily a good idea. So don't be too quick on the draw to call something hasty generalization. Look at other options first, just for that reason. This involves reasoning from a sample to a general population. Right? So there's a specific kind of argument that has to happen for hasty generalization to even be in the running as what kind of fallacy is being committed. So for example, you've got a factory that produces bottles, and you want to know how many bottles have defects. Now it produces 50,000 bottles a day, let's say, right? So you're not going to check every single bottle. What you do instead is you do a sample, right? So you figure out, and you can get into all kinds of sophisticated math about the statistics, how to ensure that you're doing a good sample. But let's say that it turns out you can take a sample of 100 of the bottles, and if 2 of those are defective, you can bet 2% overall are going to be defective. So it's 50,000, so 1,000 defective bottles, right? That's your conclusion. So you started with a sample, the 100 bottles. You conclude that out of the 50,000, the same proportion will be defective. So you're concluding that the general population has this feature in the same proportion as the sample. That's reasoning from a sample. And the argument has to be doing that to even consider that it might be hasty generalization. That's what I mean by generalization. Sometimes people think that sometimes people use the word generalization to mean generalizing as in making a general statement. It's a lot of times a stereotype. Say, oh, well, Irish people, they're all drunks, you know. That's a generalization. That's not what we mean here by generalization. It's this type of reasoning where you start from the sample, you go to the general population, okay? Now, this type of reasoning is a very useful kind of reasoning. And as I said, you can do entire courses and majors and PhDs on the subject of statistics, right? Is basically what we're talking about. But in a very general sense, there are 2 major problems that can happen when you're reasoning from a sample. One would be that the sample's just too small. Sometimes people even do a sample of like 1 or 2. And people do this with, say, people do this with things where they want to conclude the subject too. So sort of psychological stuff might come into it, but the problem with the argument, suppose someone says, well, they say smoking is bad for you, and people die if they smoke. My grandfather smoked 2 packs a day his whole life. He lived to be 90 years old. So it's a bunch of nonsense, right? And what you do there, right? You have your one example, a smoker who lived a relatively long life, and you use that example and generalize as if that was going to be typical. You can't do that, right? Of course, because they've done studies with following thousands of smokers versus non-smokers. The non-smokers tend to live longer, overwhelmingly. So I mean, this kind of, and adding 2 or 3 more is sometimes a response people have. You point out, okay, one person, your grandfather, lived to be 90 and he smoked 2 packs a day. They say, well, it's not just him. I know the old lady down the street too smoked 2 packs a day. And I bring up like 3 more people that I know of lived a long time even though they smoked. And adding to that 4 or 5 cases is still a sample that's just too small. Right? And so this sometimes is referred to as using anecdotal evidence, generalizing from anecdotal evidence. If you're generalizing from anecdotal evidence, right, then you have a couple of stories, and then you generalize off those stories, which is not really a legitimate generalization. Another problem that can happen, and this is a separate issue, the sample could be biased, meaning that even if it is a large sample, it could be a biased sample. So for example, I say, you know, we did a survey and we polled 10,000 people and asked them if they would vote for Hillary Clinton in the election. And we got 9,900 that said they would. So, you know, that's 99%, right? 99%? Yeah. So we think that she's going to win in a landslide. I mean, 99%. And it's a large sample, 10,000 people, right? And then you say, well, where did you pass out the surveys? Oh, at the Democratic National Convention. Well, gee, you know, yeah, if you're just passing out your surveys in the Democratic National Convention, you're going to have, you know, most people are going to say that they would vote for her, right? That's why they're there. So this kind of situation is a biased sample, and it's even if it's a large sample, right? The sample is biased. There are various other kind of psychological factors that go into this. One case of using a small sample to make generalizations that people tend to do is the plane crash sort of scenario, where people often get the impression that plane crashes happen much more frequently than they actually do, because it's very memorable, right? I mean, it's a big deal when a plane crashes. It's a, you know, huge ball of flame, hundreds of people die, and it's news all over the world. So you get the impression that it happens more frequently than it really does. And what you're sort of doing is generalizing off of, you know, this week there was a plane crash. It was such a big deal, right? And so you're thinking like, hey, this happens every other week or something. And really, you know, it only happens, you only hear about this maybe once every couple of years. So it's much less frequent than you get the impression. Hasty generalizations are also what's behind stereotypes, right? People draw this conclusion about like an ethnic group based on an experience with a couple of members. My neighbor, the Scottish guy, man, sits around drinking. He drinks whiskey like it's water. You know, those Scots, they just drink. They just put away the whiskey. You know, and I don't know if that's, it could be true, but just basing this off this one case is reasoning from a sample that's too small, and that's how you get the sort of stereotypes as well. So that's hasty generalization, and a warning on that is to watch out for other similar fallacies. Don't call everything hasty generalization.